Welcome to Get Your FRQ On. This question is from the 2000 Calculus AB exam. It's question 4, and it is not calculator active. In the question stem, we have a water tank with 30 gallons of water in it at time t equals 0. Water is being pumped into this tank at a constant rate of 8 gallons per minute, and water is leaking out of the tank at a rate equal to square root of t plus 1 for any time t between 0 and 120. This model is good for all minutes in the first 120 minutes. In part A, we are asked to find how many gallons leak out from t equals 0 to t equals 3 minutes. In order to determine this, we have a rate function for the amount of water leaking out. That's the square root of t plus 1, and water leaks out at a rate equal to square root of t plus 1 gallons per minute for the first 120 minutes. Note that square root of t plus 1 is positive for all x. The total amount of water that leaks out of the tank between t equals 0 and t equals 3 can be found by taking a definite integral of our rate function for that leak. So we would need the definite integral from 0 to 3 of the square root of t plus 1 dt, which we can evaluate using a simple u substitution. That would be the integral from 1 to 4 of square root of u du. That would be 2/3 of u to the 3 halves, evaluated between 4 and 1, which turns out to be 14/3. So in the first 3 minutes, a total of 14/3 gallons leaks out of the tank. It's important to understand here that even though the calculus produces a result equal to 14/3, you are typically expected to include the unit on a problem like this, whether it be gallons or some other unit based on the problem. So don't forget the unit. How many gallons of water are in the tank at t equals 3? Well, in order to answer how many gallons of water are in the tank at t equals 3, we have to account for several things. There's 30 gallons of water in the tank already at t equals 0. And water is being pumped into the tank at a constant rate of 8 gallons per minute. Also, water is leaking out of the tank, but we know from part A that over the first 3 minutes, a total of 14/3 gallons have leaked out of the tank over those first 3 minutes. So the amount of water in the tank at t equals 3 is a combination of all 3 of those pieces of information. We started with 30. Over the first 3 minutes, if water is being pumped in at a rate equal to 8 gallons per minute for 3 minutes, that would get us 24 gallons of water being pumped in. Plus, we already know that over those 3 minutes, 14/3 gallons leaked out. So 30 plus 24 is 54. 54 minus 14/3 eventually comes out to 148/3 gallons. So in that first 3 minutes, after the first 3 minutes, that is, there would be 148/3 gallons of water in the tank. In part C, we are asked to write an expression A of t for the total gallons in the tank at time t. This is a fairly straightforward application of the definite integral as an accumulator function. So we write A of t equals the initial condition 30 plus the integral from 0 to t of 8 minus the square root of x plus 1 dx, which you can simplify and write as 30 plus 8t minus the integral from 0 to t of square root of x plus 1 dx. Now, one thing you have to consider here is a of t is a function of t, but in these contexts where we use it as an accumulator function, typically the variable we're interested in is one of the bounds of the integrand. It is not the variable in the integrand. So we do need to switch this to an x or some other dummy variable. If we leave the integral in terms of t, we now have like a self-referential integral, and that would be wrong. That would not get you the information that you want. It would almost certainly cause you not to earn points for that part of this free response question. When you use an accumulator function in an answer to a free response question, please make sure that you don't use the same variable as a bound and inside the integral itself. In part D, we are asked when the water is at its maximum for the first 120 minutes and to provide a justification. Well, the amount of water will have a maximum either at t equals 0, t equals 120, or some other value of t such that a prime of t is equal to 0. Well, we can find a derivative for a prime of t. That's just going to be 8 minus the square root of t plus 1. If I set that equal to 0, that would imply that 8 is equal to the square root of t plus 1. That's a fairly simple equation to solve. Square both sides. And we get t plus 1 equals 64. Subtract the 1, we get t equals 63 minutes. Now, by inspection of the graph, we can see that a prime of t is positive for all values of t between 0 and 63, 63 exclusive, since we know it's 0 there. And the a prime of t is less than 0 for all values of t greater than 63 and less than or equal to 120. Therefore, we can conclude that a of t has a maximum value at t equals 63 minutes. How do we know this? Well, the derivative of a is positive going up to 63 minutes and negative after 63 minutes. So, by the first derivative test, we have a maximum.